triangle brackets because they get frightened. I've done talks with talk recently for a meeting of the heads and senior administrators from University Art Department. So, no data or pictures. It's a very pretty slide. Whereas this one, I'm assuming everyone here knows a bit about computer programming, has worked with data in some capacity, can probably write an equation in a spreadsheet, has probably seen it. Anyone here worked with XML? Not everyone, but a good number of hands. Jason? Excel? Right, okay. So this is not everyone, but it's more than half, so I'm going to go fairly technical. There's lots more about this in much more detail online. If anything's really not clear, you can just shout out, because if you're not understanding it, there's probably 10 other people who don't follow it either. So it's not... Right, so this is some data. It's one item of data, a datum, as it's called. Data is actually a plural word, but everyone forgets that. So datum is one data. And the most common thing in computer science is the good old linked list. A list of datums, a list of data, in an order. So the chapters in a book, your shopping list, the books in the Bible, each of these is a list of information in an order. This, I'm assuming you guys are already familiar with. I'm starting with what you'll be familiar with and hopefully getting you to using this to illustrate some things that you might not be familiar with. Right, tabular data is a list of lists where each of the inner lists is the same structure. So a list of records, a spreadsheet, a database table. This should be fairly familiar. And usually in something like a database, there's a special list, which is the list of fields. So a date order, usually in a spreadsheet, the first column is the heading. So you've got a list of fields, and each of those have values in each record. This data structure stuff should be fairly familiar and comfortable with everyone. But, okay, in a database, you can't do much with one table. You can, but it won't do anything clever. So you quickly need lots of tables, and you link between the tables. You use the ID from one table is a field in another. So if you have a list of students, and the students have an ID, but then when we have your grades, you have a different grade for each module. So we have a table for the modules, and then we have another table which is student module grade, for example, to tell us what your score was. And it starts to get quite complicated. Some people find this very overwhelming. I have to admit that drawing arrows between blobs on whiteboards is one of my most favourite activities at work. Also, it looks really cool later when people see lots of million arrows and it looks like you've been doing science or something. I would like to be photographed with whiteboards to look interesting behind me, so it gives credibility, I think. Okay. So, yeah, I've skipped to this. That's annoying. I'm missing some slides here. Sorry. I'm going to have to do interpreting. I copy and paste this out of some what is old slide things for you. It's missing tabular. Cool. No, I don't want to get chalk on that one. Okay, so after tabular data, you should all be familiar with tree data, and data where each element contains several sub-elements, or zero or more sub-elements. You've probably seen binary trees, where everything has two children, but XML and JSON are both examples of this. JSON data structures have both lists and trees, and XML is basically the same. XML, things contain things, but everything in it only belongs in one place. Something only has one point in the hierarchy in XML, in HTML, or in JSON. Right, so in RDF, it's freer. It allows you to do a lot more, which is great for expressing things, and terrible for easy, simple computer programs, because everything gets a lot more complicated, and it's a lot less constrained in the system. Right, so not just in a tree, one thing can link to several children, but in RDF, one thing can have both several children and several parents. It can link to anything. It's not really a parent-child relationship anymore, just things are related to things. And they can be related, they're always related in a direction, but they can be related to each other, they can be related in circles. This is not something you can do in XML. Right, What we do to identify things, I talked about URIs earlier, and relationships and entities and thingies are identified by URIs. So, yeah, we've already talked about URIs and URLs. So a URL locates something on the web, a URI identifies something on the web or not. As I said, rice pudding can have a URI, the wind in the willows can have a URI, but you can have a URL for a copy of Wind in the Willows, not the concept of the book. Right, so here I'm assigning a URI, looks like a web address, represents a thing. It's just a string of characters that represents a thing. The nice thing is, if you own the domain, you can reasonably be the person who decides what URIs to create on your website's domain, and so you can define what they mean. So here I'm saying the blog on the left has a URI which appears to be something to do with time, and the middle one is an event, for example this lecture. That's a person and that's a room. And then there's a each of these relationships has a URI as well. Now lots of people have already done a lot of work to define vocabularies for good relationships to use in RDF. So by default, never use your own if it's a perfectly good one of someone else's that does exactly what you mean. For example, Dublin Core's title is the title of a work, like a book. RDF Folks' name is the name of a person. So don't invent Ash Smith's vocabulary name unless it means something special that you need to express differently. Sorry, I didn't want to make it a name. It causes problems. There's a lot of skill in being able to design standalone vocabularies that don't link with everything else, and you can learn a lot by doing it, but the problem is then software has to understand what that term means, and if you made it up, then it's very unlikely anyone cares enough to write software to understand your term. If you used a very common term, then it's more likely the software will understand it. What we do for Southampton is we follow that rule, then we have two steps to defining a term that we can't find a good term somewhere else for. If a term is really specific to Southampton, like for example, what is this coding banner? This thing has a coding banner, which is our database. Or this thing has the University of Southampton building numbering scheme. Something that is literally specific to university, we use a Southampton term for it that clearly no one else should be using because it's somehow Southampton stuff. Whereas if we have a term and go, that would be useful. When we were designing data on lecture theatres, we wanted to put the capacity on, but capacity, that room capacity sounded like a useful term. In fact, thing capacity. So we defined a term called capacity, but we defined it on a namespace that wasn't linked to university, and we worked with Oxford University, so they were using it too, and that then is something that allows reuse. There's a technical term at universities called not invented here, which is no one likes to use something invented by one of our rivals because we might be giving them credibility. So when we were working with Oxford, we tried to make sure that all the work we did there wasn't obviously Oxford or Southampton, so other people could use it without their boss going, oh, I don't want to use their stuff. Petty, but it's worked quite well, and people are more inclined to pick it up when it's not linked to one organisation. Right. So to actually write one of these relationships, this is the simplest RDF format. It's called N-triples. That's what the N stands for. Triples is because each relationship contains three things. It contains the thing it's about, the idea of the relationship, and the thing that relationship's related to. So an event has a place, which is a room. It's actually a lie, by the way, I was lying. Triples actually have about 6 components, but they got called triples, and it's much clearer to call them triples because they're triples most of the time. But we'll cover that briefly, but you don't need to know too much about that yet. But it's one of those, everything is a lie when you first cover it. So this is literally just 3 valid URIs, and you can see how that's, the first thing identifies a blob, the next thing is an arrow, a directioned arrow if you were drawing on a whiteboard, and then there's another blob. Doesn't have labels, they're just ID like a database key. And then I visualised it. It's always directional. You can define a predicate, which is a posh name for the relationship, to be bidirectional. So, for example, my sibling, if I have a sibling, I am their sibling, they are my sibling. It's a thingy relationship. I haven't done math in ages. What's the word? I can't remember. There's a term for it. But you can also define it to mean, for example, it's also transitive. So my ancestor's ancestor is my ancestor, this room, this laptop is within this room is within Southampton, therefore this laptop is within Southampton. RDF doesn't understand these relationships, but systems using RDF can know that certain terms are transitive or that other thing.
Symmetric?
Pardon?
Symmetric?
Symmetric, that sounds right. There's ways in RDF you can define more detail about the relationships to say this term is symmetric, apparently, transitive, functional, and things, but it's not part of the structure of the language. You write those rules in RDF too. Right. So, more complicated. Everything can have labels, so you can actually make sense of it, because web addresses aren't very good at telling what things are, and you shouldn't really be reading any meaning into them, because they're IDs. Okay, so then we call them literals, and instead of having resource URI to a relationship to another URI, you can have a URI which has a relationship to a literal. Literals can be strings, dates, Boolean, integers, floats, basically bits of data. So those get written like that. The second one is linking the event to the name of the event, the actual label for the first event where I used this particular slide. Now, this is Turtle. Turtle is exactly the same format, but with a few shortcuts to make it less mad. Because writing out, as you can imagine, writing out like a 50-character ID for the 50-character ID for the relationship, 50-character ID for the thing you're linking to, repeat for 20,000 triples is really, really boring to write by hand, hard to read, hard to debug, and a waste of disk space. So, Turtle is probably my recommended format for RDF. It's the one that we use when we have a choice. There are other formats. The original format was called RDF XML, and it was written by very clever people getting carried away and making 10 different ways to do everything. It's absolutely a pain in the arse to use. Don't use it unless you have to. Its advantage is it's an XML. And always read and write RDF in any format using a library. There's tons of libraries, Java, PHP, every other language can read and write RDF, so don't do it by hand, because you'll miss something. If the library has a bug fix it, but most of them are pretty stable now. So that, and at the top you can see the prefixes, which, because both namespaces, namespace is just a bunch of stuff on the web, in the same directory on the web, or in the same fragment with thing which ends with a hash. So these are the prefixes for common vocabularies, where if someone wants to find a load of useful terms, like terms for talking about rooms, or terms for talking about books, or terms for talking about Pokemon, really. Those have all been defined already, so then instead of having to write out the whole thing, you have a shortcut like both that means all of that, and you can just say here, both name, instead of saying the whole thing. So it's a small change, and on something this short, it's probably less efficient than writing them out. But once it gets to 1,000 triples, suddenly this is much more compact. So you generally put them at the top of the file. More recent versions of this allow the prefix things to be repeated later in the file, so you can even change what it means. Not all libraries understand putting the prefix after the top of the file and putting it in the middle. Specifically, the one you're about to use is mine, or you make them partially mine, and it doesn't understand that because I have never fixed that bug. So don't put prefix anywhere but the top in. Right, so the next thing you can do is use a semicolon to repeat additional facts about the original, about one thing. So we're talking about the event up here, and instead of saying event has this time, event has this place, this event has this time, this event has this place, you can skip the repeating the events code every time by instead of using full stop, we're using a semicolon, and so there's semicolons here, and that means the next thing also relates to the same subject as the previous one. And, yep. Right. So I haven't shown it on here, but you can also have several values. Say there were 5 speakers, instead of writing prog speaker, prog speaker, prog speaker, you could do the IDs, the URIs of all the speakers with commas between them. So this is just a way to write this in a more compact way. This isn't a very complicated data structure, it's just a way of drawing graph data, basically in a way that can be understood by the computers. The real value of it, of using URIs, is that they don't clash. If you use URIs that are based on a web space you control, you can be confident that no one else is randomly using that to do their data. But if you use URIs that deliberately that other people have used, it means that you've used something from the Southampton namespace to say, talk about this room, and that's useful. When 2 of you publish data about this room, your data now matches up automatically. If you join 2 data sets together, they both talk about the same IDs, even though neither of you work together. The other advantage there is, one thing about URIs is they identify one thing, but many URIs can identify the same thing. For example, I have an ID for Southampton University, but so does the Government Open Data Service. They define their own for the university. Those IDs generally mean the same thing, and you can declare 2 IDs to be the same thing, but that's an opinion. Whether or not Batman is the same as Bruce Wayne is quite a complicated issue. If you're trying to poison Batman, then Bruce Wayne will also die. If you're trying to invite them to talk at your birthday party, it's going to make a big difference which one you invite. So for some purposes they're the same, some they're different. Right. All of the Data Southampton pages, that's not the right one, that's the one I wanted. So this room should hopefully look familiar. This is the page on Ash's service for this room, and this has a URI here. And all of these pages are available as HTML, because humans like HTML. It turns out that's a really good format for reading stuff. But they've also RDF XML. This is the horrific one that you shouldn't be using. It'll make you sad. And if you ever need to, there's lots of tools that can convert things into and out of RDF XML into Turtle and other things. This room has bunch of information about it, like the fact it's got a PC, it's got a photo. Oh, the capacity, what we just talked about. That is using that term that Oxford used too. And room, whether it's busy or free, and then these links to other formats. So the Turtle. There we go. So big Turtle file. And then we've also got N triples, which isn't linked in here. But if you ask for N triples, this is my shopping list, that's not what we want. Entry? Yeah. Oh no. I loaded it a minute ago, just I had it in my hand. Ah, there it is. Sorry, other screen. So that's a big N triples file. So it talks about this room, it has a type, sorry? Turtle, sorry. Don't keep me honest. It's a big Turtle file, so you can see that there's that this room has a feature, and then there's lots and lots of features, URI features with comments between them. If your computer doesn't give enough information, it can always look up any of these URIs and get more up triples about that URI if the person who's running that web server has decided that's what they wanted to do. In practice, that can happen half as much as we'd like, but it's the theoretical way you do this. Okay, back to this one. Right. That is the official titles for part of the triple. Anytime you see it in documentation, the first bit's the subject, the next bit's the predicate, and the last bit's the object. The nice thing about these is each one represents a single fact, and facts can be combined in any order. The ordering of a bunch of facts doesn't matter. So it doesn't matter if I said the sky is blue and I like cheese, or I like cheese and the sky is blue. The ordering had no impact on the state of how true those are. And a bunch of facts or triples is called a graph. A mathematical graph, not like a pie chart graph. They get grouped together, and most databases that store triples remember what graph a triple belongs to, so that you can filter, for example, to say, only give me triples from this data set. We have to do this sometimes, for example, because two data sets have different names for this room, and are we using the nice name for the room or the official name for the room? And things. But the other thing about things is, if you join, look, animation, policy stuff. If you join two sets of facts together, what you have is a bigger set of facts. And unlike most, you can't just merge two trees, but you can merge two graphs. Without more information, you can't join two XML files together, but you can join two RDF files together, because all an RDF file does is encode a bunch of triples in no order. One problem with this is, if you want to do ordering in RDF, it's a bit of a pain. There are triples that mean, there is a predicate that means first item in a list, second item in a list, and things. It's not great at that. There's certain things it's really good at. If you have a billion pieces of data that are all the same strict structure, you might as well use a spreadsheet. You might as well use a database table. It's much more efficient. Where this is really powerful is when you do have data that's different shapes, where it's incomplete, where different people are publishing in slightly different ways. You can join it up and end up with something meaningful at the end. Right. So I've talked about 303 other. The idea is, when you resolve a URI on things like building, the computer says, right, you're a web browser, so here's a web page about it instead. Go here. You're a semantically aware thing, then you say you can read RDF. Well, in that case, sir, go to this URL and ask for the RDF. And your web client actually says, I prefer HTML or I prefer RDF. This is fiddly, and while it technically was the best way to do these things, it made it hard to program, and I think it might have been a design mistake. The really cheap and cheerful way to do it is you make all the URIs a fragment. So a URL of a real page hash something, and then you put, and you don't have those fragments mean anything, but if you resolve them, you just get the document, but the string is different. So you have all the IDs for the things defined in a file as fragments in that file. So hash me, hash room, and so on. And that's really simple, and you don't need any fancy Apache configurations to do. So this is what a lot of people do because it's so much more convenient, so it looks expressive. So, Graphite is a PHP library that I wrote for playing with this stuff, so I will promote that one. There's plenty of other tools I'm sure you'll hear about. I like jQuery, so I tried to make something that was fun to program with, and a few people have looked at me, oh, that is fun. And so I tried to make it as easy as possible. Sparkle, we hearing a bit about next week? Okay, there we go. Okay, so Ash will talk about Sparkle next week. And Sparkle is a way to query big databases of triples. dbpedia.org/Sparkle lets you query triples based on Wikipedia's box. All those boxes on the side of Wikipedia someone turned into a database of something like 500 million triples. And you can then query it to find people who went to Southampton University and like cheese, or whatever's in Wikipedia, and work for the Conservative Party. That's an example of Sparkle. It looks like SQL. Do not think it's SQL. The more you know SQL, the harder it is to learn Sparkle. If you've never done SQL, it's actually probably easier to learn Sparkle because you won't make any assumptions. Effectively, every single statement in Sparkle is adding another join in a join, and in SQL terms. And it's very easy to get very, very muddled when you've learned SQL. So even though some of the words are the same, don't be fooled. Right, common vocabularies in RDF listed here. Sotten is not a common vocabulary, but it's what we use for our own terms. Now this site is run by a nice chap, I think, in Edinburgh now, whose name I can never pronounce. It's something like Richard Secondary. And it's really useful. It's just a list of all the most popular prefixes and what the long form is and what the common short form is. So it's got the most lovely API. If you're doing, for prefix.cc, you can ask for DC terms, and it will give you the common thing, and you can ask for DC terms dot turtle, and it will just give you the header for turtle. And if you're doing a road, I don't know. Oh, not open August, how I open it. Yeah, it will just give you all the headers, you can cut and paste them. If you're as lazy as me, I mean the good kind of lazy, there's no lazy that hates stupid work. This slide really makes my life easier. Okay. So, what we've done at Southampton is we've done an auto-discovery of open data. I talked about how excited I was about data from organisations, and the problem with it is you can't find it. And where I showed you discovery, being able to get the data that you assume exists is far more powerful. So we came up with a way to find specific data from an organisation based on their homepage. No one knows what the URI, the University of Southampton is, but you all know Southampton AC UK. So our theory was to make something where you could discover meaningful open data just based on the homepage. We did a very simple way, either a magic URL like robots.txt that you go to .wellknown open.org and it redirects you to a document describing the organisation, or on the header of the website you put a link to the open data about the organisation. Then in that document you'd say, we are University of Southampton, we have some data about our car parks. It is in this standard car park data format that doesn't exist yet. And it's an open license. And what we did to kick this off with equipment was people say, we have our equipment data, it is under this license, you are allowed to reuse this data, and even if it's a spreadsheet, it is in a spreadsheet conforming to this standard, but there's a URI to say, spreadsheet conforming to this standard, and then we can actually find it from the homepage, find that they've given us permission to use it, know what format it's in, and download it every morning to create our database. So we've got that's used currently by about 40 UK universities, and I invented it, so it's really cool. In all my default examples, we use Creative Commons 0, which is public domain, and this was actually just me being sneaky, because most people just cut and paste the license without really caring, and Cambridge University seems to have done that. So when everyone says, is it okay to be public domain, I don't think Cambridge do it. And then hopefully by the time someone at Cambridge goes, oh, we should be doing this, no one else does it. So, right. So what I'd like you guys to do now is have a go at writing some Turtle. This isn't a test, this is just a bit of a practice. Get your hands dirty, that's fine. Try it out. I'll be around, Ash is here, and if you have a look at that workshop, if you go to the second page, which is the checker page, that will let you actually type the Turtle into a web form, submit it, and it will tell you if it's worked or not. So it'll give you error reports if you've got the syntax wrong, or if you've got the RDF right, but what you said in RDF doesn't make sense in some way. So you guys want to give this a go? And if you want to ask questions, I should probably do, before we go on, does anyone have any questions? That's good. Either a really good sign or a really bad sign. Right, so if you guys want to go and have a go at this, this will be still online later, so if people desperately need to dash for lunch or something, I'm not going to be offended, but if you want to stay and have a go at it, please do.
Well, I mean, can we just have a round of applause for... I don't know about you guys, but I think I'm going to stay, hang around and learn some more, but you are most welcome if you want to leave.
So next week, Ash will be talking more about what he's done at Southampton, which should actually be data that's relevant to services that are relevant. Actually, a lot more relevant.
这个外讲的还挺好的。
比上两个
对，这讲了不少。